A very warm welcome to all of you. I really appreciate being here and also to transmit the greetings of, you saw already the Director General, but all of us in the Directorate at CERN. We've already heard it. CERN is the world's biggest laboratory for particle physics. What we try to do is to understand the most fundamental laws of the universe and the fundamental particles. And you see here, let me just see if I can make does it have a pointer? There is here. Okay, so you see here, of course, our flagship accelerator, the Large Hadron Collider, which straddles the border between Switzerland and France. And I will be speaking a little bit more about that later. There are 4 pillars that underpin the mission of CERN. First and foremost, fundamental research in particle physics. This is carried forward by a very large and extensive international collaboration. And in order to answer the questions in particle physics, we need to develop cutting-edge technologies in a variety of fields. We already heard several of them in the introductory remarks, and all of this together provides a very rich platform for education and training of the next generation of scientists and many other professions. And I'll just say a few words about each of these pillars in turn. First and foremost, fundamental research in particle physics. What we try to do is understand what the universe is made of. We study the elementary building blocks of matter and the forces that control them, going all the way from matter here. Everything around us is made of matter, but of course that's not a fundamental particle. We can break that down into atoms, and this is again not a fundamental particles, but it is a nucleus which is surrounded by a cloud of electrons. And again, the nucleus is not fundamental. That can be broken down into protons, and they again can be broken down into quarks. And this is what we today believe are fundamental particles, so they cannot be cut into smaller pieces. So all of us are made effectively of quarks and electrons. I think even the ambassador is made of electrons and quarks. I think that's quite reassuring for all of us, even at that level, quarks and electrons. Now, why is this important to understand? This is because that also helps us to understand how the universe has developed over time. And you see here a representation of the universe from how it started with a Big Bang and until today. And this is an evolution that has taken 13.8 billion years. And if we try to understand how the universe has evolved over time, there are different methodologies that we can use. We can use telescopes, either ground-based or space-based. And with those, we look into the night sky, and effectively we look back in time, because the speed of light is finite. So the further we look back, the further we look back in time. But there is a barrier here, because in the beginning, the universe was so hot and so dense that light couldn't propagate. So no light comes to us from that epoch. So we need complementary methods in order to understand the very first fractions of a second after the Big Bang. And this is where particle accelerators come in, because they help us reproduce the conditions a fraction of a second after the Big Bang, so that we can understand how the universe evolved in those very early moments. In order to do that, we developed technologies in three key areas: particle accelerators, particle detectors, and large-scale computing. And in the very nice words we heard here in the beginning, we already heard about the value of these different technologies. Our flagship, Large Hadron Collider, is our flagship accelerator, 27 kilometers in circumference, about 100 meters underground, on the border between Switzerland and France, consisting mainly of superconducting magnets like this one, 1,232 of them, and they steer the particles around its path in the ring. And then the particles are accelerated to just about the speed of light, and then they are brought into collision at 4 collision points in 4 large experiments. ATLAS, we already heard that Slovakia has a very strong involvement in ATLAS, in CMS, in ALICE, and I will also come back to that because this is one of the other 2 LHC experiments where Slovakia is particularly involved, and then LHCb. And the LHC detectors are effectively large 3D cameras. They measure the energy, the charge, the direction of the new particles that are formed in the collisions. They take about 40 million pictures a second, but only 1,000 of them are stored, and they are built by large collaborations that cover all of the globe effectively. And of course, Slovakia is one of them, and we're extremely proud of that. Now the particles have been accelerated, they've been brought into collision, new particles have been formed. So that means that we have large amounts of data that need to be stored. And that happens in a distributed computing infrastructure called the worldwide LHC computing grid. This is effectively a precursor of cloud computing that is used to store, distribute, process, and analyze the large amounts of data that come out of the Large Hadron Collider. This is the largest scientific data set in the world, effectively. But beyond that, CERN has a very rich scientific diversity program with a number of other experiments, and Slovakia is involved in several of them, and I'll come back to that in a little bit more detail. Now, you would think that after close to 70 years of work, we would be at a point where we know it all, but one of the great truths in life is that the more you know, the more you realize that you know very little. So effectively, what we see around us is only 5% of the energy and the mass that's in the universe. So there's still 95% left to understand, and there are very important questions in fundamental physics still to try and answer. So that means that the journey continues. The Large Hadron Collider is now being upgraded to what's called the high luminosity phase. This is includes the installment of new cutting edge technologies that will give us 10 times more collisions than what we have today. That gives us access to more rare phenomena. It gives us greater precision in the results that we have, and that also potentially increases our discovery potential. And this is now in the process of being installed. And the new phase of the Large Hadron Collider will start in 2029 and will run until about the 2040s. But the journey does not stop there by any means, because we are already thinking about what comes beyond that. We already heard also in some of the introductory remarks about the future and the thinking around this. And CERN works according to what's called the European Strategy for Particle Physics. This is our roadmap, which is based on a bottom-up approach and discussion in the particle physics community, and then adopted, approved by our member states. And the latest edition was updated by our council in 2020, and that sets out the priorities for the future. First and foremost, to fully exploit the high luminosity phase of the Large Hadron Collider, but also to look beyond. Very importantly, we're now in the process of a feasibility study to investigate the technical and financial feasibility of a future energy frontier collider. Now, the current estimate is about 91 kilometers. This would also be in the Geneva Basin. You see it here. So the Large Hadron Collider becomes like a little cute injector potentially to a future circular collider. The feasibility study will conclude in 2025 and then becomes an input into the next strategy process. And maybe by the end of the decade, our member states will be in a position to take a decision as to whether to go ahead or not. And we think there's a very bright future here, many opportunities in terms of the science and the technology development, the R&D, and we very much hope that Slovakia will continue to play a very important role in shaping that future, also in the context of the feasibility study that is now ongoing. All of this is taking place under the banner of environmentally responsible research. We're very conscious of the potential impact we may have on the environment. We're working actively to minimize the impact of our activities on the environment, but we are also working very actively to go through the technologies that we develop and to take forward those that we know can help also to address the environmental impact of all of our activities together. So we try to make sure that the technology development at CERN also serves society as widely as possible also in this area. Now, all of the science, the technology development is carried forward by a very extensive collaboration. We already heard it. CERN was founded in the aftermath of the Second World War to bring Europe together in a scientific project, and also seeing science as a glue that could bring nations that had otherwise been at war back together again. And next year we celebrate 70 years of that endeavor. So 12 founding member states have become 23 today. And of course, we're extremely pleased and honored that the Slovak Republic is now one of our member states. And we also have collaboration agreements with about 50 other states outside of the member states and associate member states, and it really is a global endeavor today. A budget of about 1.2 billion Swiss francs, staff around 3,500 in CERN payroll, but most importantly is this scientific community of about 13,000 scientists that come from all over the world. And it's interesting to break that down a little bit further. You see here about half come from our member states and about another 4,000 from our associate members and observers, and about 10% from non-member states outside of that range. And I think that's particularly interesting. And you see here, I think, two numbers that are very interesting. We have 70 users that are based in institutions in Slovakia, but also we have, when you look over here, we actually have 117 users that have Slovak nationality. That also means that there are Slovak nationals working in institutes elsewhere. And this is, of course, because they're particularly attractive also to institutes outside. And of course, that speaks to the high level of the scientific community in Slovakia. Technology and innovation, we heard very much about this also in the introductory remarks. Fundamental research is, of course, a driver of innovation in a number of fields. We already heard about the World Wide Web. Sir Tim Berners-Lee was a staff member in the CERN IT department in the 80s when he developed the protocols that we all now take for granted. But there are many other areas where particle physics has really driven technology development with a very positive and a very lasting societal impact. And one of these areas is medicine and healthcare, where technologies that have come out of particle physics are applied in cancer therapy, in diagnostics. You see here also, when you talk about diagnostics, some of the latest is pixel detectors that are used for high resolution 3D color X-ray imaging. And some of these technologies have actually come from the ALICE experiment. And you actually see a Slovak imprint here because also some of our Slovak colleagues have been involved in this. So this is actually, this comes also from the incredible scientific community here in Slovakia. And also the production of innovative radioisotopes for nuclear medicine research. Now, education and training, this is something we talked a lot about today, and it's really extremely gratifying to see that we have so many young people also with us today, because CERN really opens a world of career opportunities. Here's a plot that we're particularly proud of, because you see the peak here at 27, and this is because at any one point in time, we have 3,000 PhD students working with us, so doing their dissertations in their home institutes, but coming to do their research at CERN. Obviously, some of us are also quite encouraged that the tail seems to be quite long. It seems that particle physics is good for the health. Particle physicists stay around for a long time, and it seems to give you longevity. And the further you get on in life, the happier you are to look at this side of the plot than this one. But you can also see that they don't all stay in particle physics. The field takes only about 20% of those who come out with PhDs. Many of them go into other fields, many into industry, government, and other areas. And this is because the skills they developed in particle physics and at CERN are so prized in other areas. And this is, I think, the most immediate knowledge transfer that you have from particle physics is through the people that are educated there. So CERN has a series of training and education and outreach programs, and we see Slovakia taking very good opportunities of all of them with students and with teachers and also participants in our hands-on activities. And this, I think, is extremely encouraging, and it's an incredibly important return to Slovakia for its membership. Now, we're here today to mark the 30th anniversary of the membership of Slovakia. And of course, today, Slovakia is engaged through 6 different institutions at CERN, and we were extremely honored last year to host the president. And you see here the president with members of the community. I think some of them are in the room today, and it's very nice to see you also without the president, but of course, particularly nice to see you with the president at the time. Now, Slovakia has a wide-ranging involvement in the LHC program, has provided extremely important and sophisticated hardware, both to the ALICE experiment and to the ATLAS experiment. But I just want to highlight that it's not just hardware. I think this, I don't know if this is a particular type of software, because this is, of course, a person. So you can see that the engineers are extremely hands-on when it comes to the work in the detectors. So extremely grateful for that. But very important contributions to the experiments. Also contributing very actively in the fixed target program over many years, providing very important instrumentation also there. And I think actually I think some of you will recognize some of these photos because you have been part of developing that. So thank you very much for that. Also, Slovakia has made very important contributions to the construction of the Large Hadron Collider, in the design, in the development, and of course also in the operation of key parts of the accelerator chain. And this is an area where we also see great potential for Slovakia to strengthen its involvement as we're looking at the R&D for the future, both for the accelerator and also for the detectors. Slovakia also supports very strongly the IT work at CERN. Slovak engineers and IT specialists have developed very sophisticated software for physics analysis, but also for business applications at CERN. And you see here also data is stored on a storage system that are actually designed and maintained by Slovak experts. Again, you see that Slovakia is involved across the 3 pillars of CERN's work when it comes to the science, to the physics, to the engineering, and also to the IT. So Slovak industry is a particularly strong partner for CERN. You see here some of the contributions that Slovak industry has made. Slovakia is really leading in many areas. I think it's also the envy of some of our other member states that are not able to have the same level of industrial return. And of course, it speaks extremely highly to the quality of the work that happens here. We have been blessed with many high-level visitors over the years, and we've been very honored to host them, several presidents, but also parliamentarians, government representatives. The Academy of Science has been there on several occasions, university and research institutions. We're extremely grateful for the strong support from the permanent mission in Geneva. That's very valuable to us. And of course, also we have many colleagues who are hosting the many students who come every year, and beyond the VIPs, they are some of the most important guests that we have. There is a very strong engagement in education and training. We already spoke about the students, but also the teachers that come every year. Over 600 high school students come to take part in the organized opportunities at CERN, but beyond that, many others also come just as visitors, and we're extremely grateful to have all of them there. But of course, education and training is not just one way. It's not just us giving our education to those who come from the Slovak Republic. It is also the Slovak Republic educating us when it comes to culture and gastronomy. So last week, we had the great honor of having Slovakia be the honorary host of the traditional dinner of the CERN Council, and we were able to we tasted both food and wines from Slovakia, which was extremely very well appreciated. Yes, I think the ambassador is laughing because I wasn't entirely. There were too many vegans in the audience, but it just goes to show that Slovakia also shows its culture to everybody who's at CERN, and I think this exchange is extremely well appreciated. So thank you very much, in particular, to the ambassador for that. So the journey continues. There are many, many unanswered questions in physics, and we very much look forward to the Slovak Republic continuing to be a central part of that collective effort. Congratulations on the 30th anniversary, and we look forward to 30 and many more.